Okay, so thank you everybody for coming today. Welcome, a very warm welcome. As you can see, it's Michigan, but still a very sunny day with very pleasant weather. So this is really a gift for us, and it's just a joy to see you here as well as a sunny day. So what can be better than this context to start our graduation ceremony? I am Miki Bano. I am the faculty director of Integrative Systems and Design Division, and I will be the master of the ceremony today. I would like to thank to our director, Ted Kudlicher, who put together this program today, and he prepared for me a very nice speech. So we are here to honor and celebrate the outstanding achievements of our graduates. This semester was very important for us, and we are welcoming friends, family, and classmates here today. I'd like to thank everyone for joining this event, and also we are welcoming everybody who is online. Do we have everything set up, Nick? We can see the online students, virtual attendance. Do we have? Okay, perfect. Thank you. So for those who are virtually present today, would like to encourage them to be active in chat and engage with our event today. So thank you for helping us to celebrate the accomplishments of our graduates, and thank you for the support you provided during this incredible journey. For those participating virtually, as I said, we would like to thank to be even at this distance still with us today. We are very fortunate to have many of these ISD staff who put together this event, and I will not list everybody because we have a great and outstanding group of staff who are very helpful, and always they are preparing the outstanding kind of events. We raise the bar, as you can see. So today we are very fortunate to have in the room some of our program directors who probably you know them very well, and they were very helpful along the journey. And we'll have some speakers, and we'll mention Professor Robert Bortley, who will be one of the speakers later today. We'll also want to hear some feedback and opinion from our graduate students and from the ISD Alumni Leadership Board. And we'll have a very important speaker today, an alumni of University of Michigan, of ISD in particular, and a very highly ranked alumni as an example of a professional development and a role model for all of us. So at this time, we have to start our agenda and welcome and introduce the ISD Manufacturing doctoral candidate, Bhavana Komaraju, who will introduce our first speaker, the ISD GSAC representative and the chair of the GSAC. So Bhavana, I would like to invite you here on the stage.
Well, hello everyone and good morning. Very nice to see all of you. And first of all, I want to congratulate everyone who's graduating today. It's been lovely to see all of you. Go Blue. It's been a pleasure to be the ISD College of Engineering representative since the last year. What has been very special is that I've had the experience to learn across different departments through different activities. So today on this special occasion, it is my pleasure to speak about our newly elected ISD's very own Graduate Student Advisory Committee, the ISD GSAC. The ISD GSAC is a special committee that's used to celebrate diversity and brighten up our spirits over and beyond. So this year, as a first step, we have planned for the best of college experience for all of us. And also we have created an agenda and a funding plan for various activities planned throughout the winter semester. So this committee meets several times throughout the year to provide feedback to the ISD leadership, plan student events, and brainstorm other ways to foster an active student community. Well, that's like enjoyment over and a cherry on top of the cake. So we had a wonderful election season this fall, and I have to congratulate all our representatives, the staff, the College of Engineering for making this possible rapidly just within 2 weeks after forming the GSAC committee and the election. So I'm so proud, and it's been overwhelming response from the students, and it has been a remarkable journey. So please join me in welcoming our ISG's newly elected president, Anirudh Krishnamurthy, to the podium to learn more about the events we plan.
Thank you, Dr. Bhavna and Dr. Banu, for your kind introductions. Good afternoon, esteemed faculty, alumni, staff, and most importantly, the exceptional graduate students of ISD. My name is Anirudh Krishnamurthy, and I am the president of Graduate Student Advisory Committee. Today marks a momentous occasion, a culmination of years of hard work, dedication, and relentless pursuit of knowledge. We gather here to celebrate the completion of academic milestones and applaud the remarkable journey undertaken by these outstanding individuals who now stand on the threshold of a new chapter in their lives. Let's take another moment to collectively acknowledge the incredible achievements of our graduate students. Moving on with the event for today. For those unfamiliar, the ISD Graduate Student Advisory Committee is more than just a group of students. It is a dedicated team committed to enhancing the graduate student experience within the ISD. This fall, we started with Festival of Lights as part of a diversity, inclusion, and equity, and a Thanksgiving get-together as kickstarters for which we had outstanding student participation. I'm thrilled to share a glimpse into the exciting events that we have in our calendar. They represent opportunities for growth, connection, and shared experiences that will undoubtedly shape the vibrant tapestry of our community. Your participation, enthusiasm, and ideas are welcome and essential in making these events truly extraordinary. At this time, I would like to recognize and introduce the driving force behind many of the initiatives and decisions that shape our academic community: the dedicated representatives of the Graduate Student Advisory Committee. Graduates, in closing, let me say your achievements today mark a personal triumph and a collective step towards a brighter and more enlightened future. Armed with your education, go forth and make a positive impact on the world. Embrace the challenges, champion the values you hold, my dear, and be the architects of the future. And most importantly, go blue. Thank you.
Thank you, Bhavana and Anirudh. I can tell you that I'm so excited about the GSAC this year. We started our semester, and it was not clear if we'll have a GSAC or not. And I asked Bhavana, because she's the College of Engineering representative, to organize some elections. And we did a very democratic elections in two rounds. And fortunately, we had a lot of candidates for president, vice president, and treasurer. We selected, and the next day, I think never happened this, I had a list of events they want to start, and not all of this, but they said next week we have the first event, we invite everybody. So they are so active, they create a very vibrant environment, and this is what we need. Thank you. It is now my honor and pleasure to introduce our distinguished speaker today, Sam Haber. Sam earned a Master of Engineering in Automotive Engineering in 2019 and a Bachelor of Science degree in Electrical Engineering in 2013 both from University of Michigan, double alumni. So what started as a confusing walk through Gigi Brown, you probably know the building on Hayward Street. It's not easy to navigate because it is a labyrinth, and we don't blame. You were confused in 2013 when you walked for the first time. But that one, it was actually a life-changing experience that you enjoy along the way with participation in Michigan Solar Car team. And 2 years later, in 2015, after working on batteries and solar panels, Sam helped found the Michigan Hybrid Racing Team. He was a co-team captain and chief engineer. So this interdisciplinary team quickly grew as and evolved over the years into an all-electrical racing team, now known as M Racing. And this is one of the achievements of the College of Engineering, and we are very proud because they are very successful, and even nowadays we are working on this. So after graduation, Sam was hired by Toyota to focus on customer electronics strategy and learning what customers value most. He next moved to General Motors and began working on all aspects of vehicle electrical architectures, including active safety, system engineering, and electrical powers. During this time at Toyota and GM, Sam earned 6 patents. So an innovator, not only a great alumni. He left GM and joined the exciting opportunity to getting back to his roots in EV powertrains, and was recently promoted to Vice President of Automotive Business Development at Our Next Energy. You probably know about this company. It's hot topic, electrical vehicles, everybody needs Sam. Acting as the voice of our customers with broad multidisciplinary systems engineering, he works with the business development, engineering, creative, and strategy teams. As a strategic senior engineer and product owner with more than 10 years of experience in automotive and multidisciplinary systems, Sam is the best communicator who is well versed in reporting to executives and diverse topics. He is a role model, and he also has skills demonstrated skills as a leader in growing large teams and spinning off new areas, and a proved big picture innovator who looks at how things could be, not just what they are. In addition to this daily job, Sam is president of the ISD Alumni Leadership Board. And with this, please welcome Sam, and let's listen about his advices.
Hi, everybody. Thank you. I very much appreciate that. Gigi Brown was a lot more confusing before they did the renovations. There was no signs, there was nothing. You were on the second floor, then the third floor suddenly, and you didn't get on a set of stairs. In that walk there, I managed to find a fifth-year undergrad who had taken a semester off and was continuing on and was graduating that semester. And she helped me and another student out find our way, figure out where Engineering 100 was going to be. This was back in 2008. And in that, we got to talking, and that's when I got taken to a solar car meeting. And that's when everything started to change. So that theme of people helping each other is a very important thing. When I was talking with Ted about what to come and talk to everybody about, there's a couple of different topics. I could talk about a lot of things in my career. I've jumped really quickly through different roles, get an impact, 1.5 years, 2 years, get pulled into something else. But looking at everything that it could be, that theme of people is a very strong one. So as I get into, right here, like what is ISD? We're gonna have Bob talk about systems. I see Nigel back there for design. I wanted to talk about the integrative part. What does it mean to be about people? And so I shamelessly took a screenshot on the ISD website. Some of these slides are a little rough, but they're carrying a good theme through them. that it's transforming lives through excellence, creativity, and connection. And that integrative part is the connection part. So with that, what I want to talk about today is that organizations that you'll end up going out and working with are systems of people. You'll be able to think about them as different components and how they interact with each other as we get in that today. So first, I want to give you one point that people have backgrounds. And that seems kind of silly, but it's a thing a lot of people forget. There's an aspect called the Dunning-Kruger effect, where people who don't know a lot about a particular area absolutely think there's not that much to know, so they overestimate how much they know. But it's also true once you become an expert in an area that you also underestimate the knowledge gap. You think everyone has a strong foundation in certain areas. So these systems of people have interfaces. You've got electrical components needing mechanical packaging, and software needs to do a thing, and supply chain needs to get things everywhere even if they don't understand what the parts are, and finance and business development and validation. There's many different people doing different things. And in that Dunning-Kruger effect, remembering that everybody has background, those interfaces get really confusing. Mechanical engineers will assume that everybody knows that the part is always plus or minus a dimensional tolerance. Or in the manufacturing, people will know that everyone thinks and understands completely that there's a yield rate. Not every single part is going to be good. Those interfaces between those different spots are really where that integration lies. And I think the graduates from this department have a unique aspect, and I think it should be brought as a forefront. You come in with systems engineering, you come in with mechanical engineering, with electrical engineering, chemical engineering. There's a diverse background sitting here from your undergrad. When you go out in the real world, it gets much, much more intense. People come from different schools, people come from different countries, it is surprising how much, and apologies to anybody from California, amazing how much an engineer from California has a very different way of thinking about things than an engineer from the Midwest, just in terms of one-off design or making a million of something and what steps need to get thought about. So in those integration points, there's a lot of background that needs to get taken into account. And so an example I want to talk about from my career, I spent a period of time at General Motors working on machine vision. For a front drive camera, it detects pedestrians, it detects other cars, lane lines, things like that. And I worked very closely with the chief engineers and the program management team, who are the boss, the main customer. And they were pounding their fist and demanding a feature get added in because it was very needed and customers were demanding it. But they did not understand how neural networks work. And the fact that putting extra bits into that neural network means you need to revalidate it. They didn't know why we didn't know what was going to come out on the other side until we had started revalidating. This led to 3-4 months of meetings where we didn't really understand what was the difference and why people were disagreeing and why they kept demanding it even though we had explained multiple times. The explanation came down to trying to describe the fact that they'd only paid enough to have like the skull of a gorilla of mental space for the camera, and they were trying to shove a chimpanzee brain into that space, and so they're cutting parts of the brain off to make it fit, and we don't know what's going to happen. They said, chimp brain, gorilla skull, and I said, yes. I said, okay, and that was the end. So the way you can try and explain something, I just want to say, those program management teams and those chief engineers, very smart, brilliant people. The type of people that we honored as an alumni just back at homecoming from the ISD group. These particular people were body engineers. They understood steel very well. They understood physical space very well. Memory in megabytes and validation of software, not so much. But like by translating those aspects into that other way of communicating, we finally broke an impasse and were able to move on and figure out what could be done for the customer. So not only do people have backgrounds that can lead to problems in communication and integration among those different groups, but they also have goals. And that's a thing that's usually kind of not said. It's something you have to read between the lines to understand what's happening with different people. Two people with two goals can usually be one of three things. Those two goals can be complementary, where they're both trying to achieve the same thing. They can be orthogonal, where they're not really affecting each other, but they're not willing to help each other either. And then occasionally they're competing. Two people trying to make opposite things happen or slightly different versions of something happening. So an example I want to give is actually from back on that Formula Hybrid team. This was 2011. Mickey's very nice, and she de-aged me by like 4 or 5 years with some of those dates. So this was even further back. It was an example very early on in the team where we had an expert on engines working on the engine for the car. It was a gas-electric car, front electric, rear gasoline. But then we also had a gentleman who was working on the composites for the car, and we gave him the task of doing all the airflow for the radiators. Made sense. He was controlling how the air moved around the car. The two gentlemen, one was an engineer with a Texas background, the other was from North Carolina, and they had very strong opinions about the right way to do something. The engine guy wanted to use the radiator for the engine that was designed for it, and the aerospace guy was trying to use tractor radiators that were smaller that he could package in different spots. By the time I found out about it as a chief engineer, there was an email thread with a lot of capital letters getting thrown back and forth against each other. The engine guy had a very strong point. He was trying to get the best performance out of the engine. And the aerospace guy had a very strong point looking at how the aerodynamics of the vehicle were going to get affected. The key thing there is kind of a reframing on the opportunity for what's available. They had different goals. But they also had a different competing goal for what they were trying to get done, or you could even call them orthogonal. But at the same time, they had a complementary goal of making the best car and getting it to competition. Through a lot of conversation, reframing that and doing kind of an open book accounting and figuring out what was available and also figuring out what was the true system requirements for the situation was very important. The engine engineer, once we were able to convince him and figure out that the reason that radiator was so expensive and robust and the best for the engine was that the engine was originally a dirt bike engine and that radiator was very protected in those aspects. We were able to get him to understand that these other radiators could do the job just as well. Because we were going to be on a racetrack. There was not going to be rocks. There was not going to be other things. It was going to be very flat. So bringing those two together, they managed to keep working together and continued on. They're still friends to this day. But very tricky situation when you're not paying anybody and they could just decide that they don't want to work anymore and be done. But reframing and trying to bring people back from competing goals into complementary goals is a very strong part of integration that ISD is a part of. And then I also wanted to point out that in these systems of people, reference frames can distort everything. You might have the same complementary goals, you might have the same background looking at something, but the reference frame by which somebody is coming at will definitely tailor their thinking and tailor the communication between these different groups. So in this funny picture I found, left, right, left, as people are looking at everything. But those anchoring points can lead to impasses and decisions. So another example from General Motors, at the end of my tenure there, I was what's called a business architect, a vehicle systems engineer, very focused on profitability, trying to not take away Chrome, not take away features, but change the circuit board so that there's less wires used, but the customer still gets everything. Change this, change that, and bring down the cost. There was a key example. This was during the pandemic, so it was very hard with physical parts. But a change on the flappy paddles on a steering wheel. They're switches. Technically, they're an electrical part. It's a complicated, historical thing. But it's a chrome-plated part, and we wanted to change it from being magnesium to being aluminum. It would save us several dollars times X number of millions of vehicles a year. It's worth investigating. But the chief engineer who had the final decision on that point was a performance enthusiast. He wanted everything to be perfect for this vehicle. This was for a driver's car. So very difficult to get physical parts in front of people. We would go to Milford, we'd be outside, we'd be playing around with things. You'd have to get the parts installed just for him to try it. And then if you needed to make a change, that was at least another week or two, just from the communication of how do you transfer the parts and get them worked on and then get them back in front of somebody. A little frustrating when he would come in and he would reach down, listen with his ear, get very close to the steering wheel with the engine off and go ting, 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 and hit his fingernail against it and just try to get the sound right. And for that reason alone, when he was driving it, he loved it, everything, absolutely. He's like, these are perfect, except that little ting, can you keep retuning this? The reason he was in that point is he came with a reference that the magnesium were better. We paid more money for them, they were better, and so they just have to be better than the aluminum in every way. And so he kept investigating. The right was the new one with aluminum, the left was the old one with the magnesium. The left's better every time. A couple of the engineers and I put it together to try and reframe it, to give him a clean slate. So we came in after another 2 weeks, and we had him test it out. And we say, well, which one do you like better? And he says, is the left one the old one? And we go, yes. And he goes, the left one's obviously better. Listen, ting, 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 ting. It's a little different. Both of them were the new one at that point. And we told him afterward in the meeting with everybody. And there was a little bit of egg on face. That was probably not like the most kosher move to do. But he thought it was funny at the end, and he had to concede that most of the time when someone's hitting the paddles, the engine's running and the whole car is going across the road and the little ting, ting, ting is not a thing. And also it was just his perception. So reframing that and trying to break biases is a thing that you should focus on. So those are 3 things I could talk about really quickly. I've learned a lot of lessons that I've been using with a lot of the young engineers on my team as we've been trying to communicate in product management, and then some of the strategy thing, particularly as you're working with customers who are even more temperamental than chief engineers. We could probably sit up here for like a 3-credit class for an entire semester. But the key thing is that integration in an organization means bringing people together. And you all coming in from ISD, you're going to sit between all of those spots. If I jump all the way back, those brown ovals, that's where ISD sits. And a lot of your activity is going to be spent trying to translate between these different organizations and improve them. You might lead one of those organizations. You might be very focused in a particular area, but you'll still be interacting with everybody else. And you are now uniquely suited to be those people to help bring large groups of people together, multidisciplinary projects and large endeavors. And so with that, I just want to congratulate you all. It's a long road out there. There's a lot of hard challenges. But there's a classic joke that maize is a very arrogant shade of yellow. When I had, back when I taught Engineering 100, I would have everybody come in and then feel very upset once they got their first grade back for their first lab report. First assignment in college kind of thing, and they had to step up. But that arrogant shade of yellow is not, I would say in that prospect, it's not about being better than everybody else at that point. It's about knowing that you're always better than the problem. And so you will always overcome that problem and continue forward. And so with that, I want to congratulate you all. I'm very happy for you. I'm very excited. Connect with me on LinkedIn. I lead the ISD alumni group. Definitely wear it proudly in everything you do. And congratulations, and go blue.
We have a present for you.
Oh, thank you.
It's all about blue and yellow maize.
Thank you.
So, ding, 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 not a thing. Remember. And actually, this ding, 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 not a thing actually saves a lot of money, because probably you know, the ISD graduates probably they know very well, magnesium is a very expensive metal compared to aluminum. Aluminum is also expensive, but magnesium is very expensive. It's lighter, but expensive. So basically, Sam saved the cost of the cars so that cars are affordable today. Otherwise, if we put some magnesium, probably we'll not be able to drive so many cars. Thank you for the inspiring speech and for the role model that you offer to ISD students. Don't be shy and contact Sam, be in touch with him, and ask advices for your future careers. Thank you once again. And now it's my honor to introduce Professor Robert Bordley. the program director of System Engineering and Design, but also the second treasurer of Sigma Theta Mu. Sigma Theta Mu is the honor society for system engineering and system-related disciplines formed by the International Council of System Engineering. ISD hosts the University of Michigan chapter of the Honor Society, and top students are initiated into the Honor Society biannual. Dr. Bordley will preside over that ceremony today. So please join me and welcome Professor Robert Bordley.
I was impressed by Sam's talk because Sam ends with M. Sigma Theta Mu, Systems Theory and Method, is the honor society of systems engineering of the International Council of Systems Engineering. So what is system engineering about? Well, it's about the innovation supply chain. Because like an M, you have a leg on one side, which is customer concerns, demands, and needs, which we have to formalize into a problem. And on the other hand, you have happy customers who are actually using something you developed to satisfy their needs. So that's this side of the M. The other side of the M, the question is, as Sam talked about, how do you connect them together? How do you go from what people need to people actually successfully addressing their need? And that's the systems engineering process, the systems V. What it involves is, now that you've got, finally, what the social real-world problem is, it's not going to be solved by one little breakthrough. Typically going to involve hundreds of breakthroughs or clever ideas by a lot of technical specialists. And so that's where the second leg is. You have to drill down to get into all those specialists and distribute the work and effort to the specialists. Give them well-defined problems that they know how to solve. You know, you're basically trying to get Einstein to help you build a bridge. And so it's how you get all these Einsteins together. And then basically, they come up with the challenges, they meet the challenges, sometimes they don't, and now you have to pull all those things together into a solution, a coherent, holistic, verified solution that addresses the need. And at that point, you've got your path from what society needs to society meeting those needs by drilling down and then integrating together. That is the Systems M, represented by my hand for Systems V. Now, the Honor Society, we have a selection committee. They met looking at the top students from the university based on system engineering programs and all programs, and they elected 4 people. And I'd like to honor those 4 people there. The first person I'd like to talk about is Ozzy the Autonomous, because he worked in trying to integrate hardware and software for autonomous vehicles. And so, Ozzy, if you'll come up. Yes, one side, and pins and everything else like that. So hopefully I've got the right name. No, I don't. Might be that one. Let's see. No. Always the last place you look, right? Yep, there we go. All right. All right. Move over here. Guess what the cameras?
You want the block M in the back.
Block that background? Okay, so move on to the background. The second person I'd like to introduce is Electric Danielle, because she works on calibration, all-wheel drives for electric vehicles. She's not here right now, but we applaud her. And now I'd like to go to what I call rock star Yash. Yash has been my GSI for 2 different courses, which had large numbers of students. Why do I call him a rock star? Well, he works on rockers, in conventional vehicles, but a really critical part. And certainly he played a critical role with me in grading all those classes, all those homeworks, all those assignments, and everything else like that. So you've been wonderful, Yash. I'll miss you selfishly in terms of your resources and help, but I'm sure you've got some great things to do, with the car industry. And obviously I'm retiree, so I'll have best wishes. So Yash, first a picture here, and then we run to the center. Now we go to the center. Behind the M. Thank you very much. And don't forget your pins. In fact, Ozzy, you need your pin. I'll bring it down. So I've been talking about vehicles, and it seems like, are we always about vehicles? Well, we're Detroit, but Dominic started in Ford, and now he's working with nuclear power plants. Pretty important stuff these days because nuclear power plants. My brother Paul ran a nuclear power plant, and he lived during the times when people were saying, we got to get rid of those, But now you got innovations coming that could really make, so I'm trying to make my brother feel better, that his life work was spent on something that's going to continue great. And so Dominic, go blue. And so with that, I finished the induction. Thank you again. And remember, the Systems Engineering V is the secret, as Sam said, to integrating and bringing people together, society needs and the needs of all our technical experts. Thank you.
Thank you, Professor Bordley, for such a nice induction, and also for the outstanding speech, as always. And you are unique. I cannot do this V.
This is okay, too.
Okay, sure. So with this, we'd like to close the ceremony by congratulating all our graduates today. We have Master of Engineering, Master of Science, and PhD students here in this room. So we'd like to wish all the best in your careers. We are here to support you, even you are going out. We'll be always supportive for giving advices, for having you here and visiting us to see how we are doing, and exchanging exchanging impressions about your new life. So thank you for all the audience, for families, friends, and roommates. It is a great day for everybody, and we'll enjoy seeing the names of the graduates today. Probably Nick will display, and this will run during the second part of our ceremony. And now we'd like to invite you to have a wonderful lunch. We thank once again to our ISD staff who prepare a very nice menu today. We hope you will enjoy. And now I would like to invite Grace and Lauren to cut the cake. It is a surprise, they didn't know. Please join and cut the cake.
Thanks, Vicky.
You are very welcome. Congratulations.
Oh, thank you.
Okay. So thank you, and enjoy the rest of the day.
Thank you.